Hello. Welcome to StackMob. Welcome to Appsterdam's WWDC headquarters here in San Francisco during WWDC. I'm Jason Harris. I'm going to be talking today about physicality, bitches, creating and designing and implementing Bluetooth smart peripherals for iOS, and more generally how the market for these is going to completely and totally explode over the next 2 years. I apologize in advance, it's kind of bright and it's a little bit difficult to actually see the screen. I know we'll be making our slide decks, all the speakers will be making the slide decks available afterwards, so if you don't see anything today, you'll be able to grab them somehow later on. I think we're going to have videos available as well. And before I get started, I'd like to thank the sponsors. Specifically, I'd like to thank StackMob for hosting this and for putting us up and for providing us with coffee and space and all of that good stuff. I'd like to thank all of the sponsors for paying for lunch and for inviting us. I'd like to thank SourceBits, who has the courtesy to employ me for letting me come and do this today. And of course, I'd like to thank Appsterdam in general and Rob and Judy specifically for organizing this. Okay, so without further ado, physicality, bitches. So basically, we're going to be talking about peripherals. But before we do that, why don't we actually take a look at just a sort of overview of where we're going to go today. We're going to first talk about what a peripheral actually is, because a lot of people, they don't really know. And if they're like my mom, for example, I tell her I work on peripherals and she thinks I'm still making apps and doesn't realize that there's an actual physical hardware component to this. So we'll talk about what a peripheral is, and we'll talk about why it's difficult to make peripherals. And generally speaking, it has been, and the point of this talk is that that is getting easier. So basically, we'll kind of go through that. Physicality, it's a bitch. The other big problem with making peripherals is communication. Your peripheral is not an island. It's going to have to talk to something, or else it's not very exciting. And communication has been a fairly large problem with peripheral design and implementation in the past. So we'll talk about that a bit. And then we'll go on to why these things are getting good, the pleasure to counterpoint pain. And basically, the biggest part here is Bluetooth Smart, which is the newest implementation of Bluetooth, which is only available on the iPhone 4S and the iPad 3 and the newest MacBooks, and I think the Motorola Droid. So we'll talk about that for a bit and why it's cool, and then finally we'll talk about how there are a couple of other industry pieces that are falling into place right now that's going to make this market become gigantic in the next 2 or 3 years. Essentially, I think that what's happened with mobile in the last 4 or 5 years is going to happen in the peripheral market in the next 2 or 3 years. So we'll talk about that. And we'll start off with what the hell is a peripheral. So again, the idea here is to actually figure out what a peripheral is. And it's this dorky Bluetooth headset that everyone's seen. It's something physical. It's physical hardware. It's an actual physical device. Usually it's portable. It doesn't necessarily have to be a massive remote control like you see on the screen here. But generally speaking, it's something that's portable. It doesn't have to be, but generally speaking it is. And as I said, it's not an island. So for the case of this talk, it's going to be something that communicates somehow with your iOS device, whether that's an iPhone or an iPad, but it's something mobile that talks to your mobile. And the way that it communicates can vary. It can have a cell signal, it can take a SIM, it can connect to the internet using your data plan, it can connect via Wi-Fi wherever you are. Both of those require that the app that's on your device needs to connect to the internet at some point and get the data back down. So that's kind of a big circle at this point. The peripheral talks up to some cloud server, and then your iOS device also talks to the cloud server and pulls the data back down. Or it can be something local. It can use Bluetooth to communicate, or it can use something like Ant+, which is what the Garmin peripherals use. It can also be wired. It can use the 30-pin connector, and it can plug directly into your iOS device. We're kind of moving away from this, but for the sake of completeness, we'll mention that those do exist. And finally, it can be something generic, like a Bluetooth headset that can work with anything, or like a stereo that can have any audio app on your iOS device stream to it, or it can be something that's very specifically tied to a particular application. For example, a lot of heart rate monitors are specifically tied to things. A lot of scales talk directly to their own software. So, to make things like this, as I said, we're building a physical device, and physicality is a bitch. If you think app design is tough, once you actually get into building physical objects, there's a whole lot more that needs to fall into place to have things work out. So there's quite a lot of reasons that physicality is difficult. The first one is certification. If you're actually selling a physical device, that device has to be certified. And at the very least, it has to be tested for radio frequency noise to make sure that it's not going to be interfering with other devices that you might have around, and this is a legal requirement. So that's the very first certification. It probably needs an FCC certification, which is the American certification for consumer electronics. So it needs to have that big FCC logo on it. Getting these things tested is expensive. It probably needs a UL, the Underwriter Laboratory certification, also expensive. And unfortunately, if you are in Canada, or you want to sell in Canada, then you need the Canadian UL, which is different. And there's even a third variant of certification, which is this kind of RU backwards UL thing. If you're selling to the European market, you need a CE certification. And if you want to sell to other countries, there are different certifications for the international market. China has one, there's Taiwan, there's something for Korea, there are a ton of different certifications. So you can see all these different logos up here. If you want to actually get all of these things certified, this is difficult. And more importantly, it's expensive. So this is one of the big hurdles that has existed in the past with creating peripheral hardware. There's another type of certification that's important here, and this is Apple's own internal certification. And this is what's called the Made for iPod program. And that actually covers iPhones and iPads as well, but the name is historical, so they call it the Made for iPod program. And this program is very heavily NDA'd, so even if I were in it, I wouldn't actually be able to discuss any details of it. But there are a few things that are known about it. If you are interested, there's a URL up here, you can check it out. There aren't really any details on the page. But the most important thing is that in addition to all these certifications that we just talked about, your hardware also has to be certified by Apple using their own third-party laboratories. And you're probably looking at about $75,000 to do this. So this is a fairly significant hurdle as well. The hardware also has to be approved by Apple. So you can't just make anything. You have to come up with a product plan and you have to submit it to Apple, and Apple has to say yes or no. Unfortunately, this is not like the App Store. You can do this before you have begun, so you don't actually go through all the cost and expense and work of building a prototype and then have Apple say, actually, no. You can do this before you begin. And finally, you have to pay royalties to Apple. And the amount of these royalties you don't know unless you're actually in the program, but I understand that they are fairly significant. So this is another hurdle and cost that has existed to building peripherals. And keep in mind, this is all in addition to the regulatory certifications that we just talked about. So another thing that's tough is the industrial design and the engineering of your product. Your product has to be cool. You know, I mean, if it looks like crap, no one's going to buy it. If it breaks the instant that you touch it, no one's going to buy it. Or if they do, you're going to have problems. You may have heard about the Jawbone Up recently. This was a consumer hardware product that had something like a 92% failure rate once it actually hit the market. And they had to basically recall them all and compensate all the people that purchased them. And I think Jawbone is now what is known colloquially as fucked as a result of this. So definitely that's not what you want to do. So you need an industrial designer and you need an industrial engineer that can make your hardware beautiful and simple and ergonomical and intuitive. It has to be easy to use. It has to feel nice as you're using it. It has to look good. You get some word of mouth advertising just if it looks good. And it has to be simple. If it's covered with buttons like that remote control that we saw earlier, that's not nice. No one really likes that. It has to not break, as I said. If you touch it and it breaks, if it's excessively fragile, these are not good things. And you have to think about what happens after the user has had it for 6 months. Maybe it's great the first day, but maybe it has moving parts that will wear out too quickly. There's a lot that needs to be thought about. So it has to not wear out, as I said. You have to think about weird edge cases. What if little kids get a hold of it and swallow it and you have a lawsuit? What if colorblind people are trying to use it and it doesn't work for them? There are a lot of weird edge cases that need to be thought about. So again, if you're accustomed to app design, you have to take all those problems and just exponentially multiply them. You have to think about making sure that it's not poison, making sure that it doesn't have lead or asbestos. The materials are very important. And finally, you have to make sure that it's something that is actually feasible. It has to be able to be manufactured. It can be the most beautiful and elegant and wonderful thing in the world, but if there's no manufacturing process in the world that can make it, you have a problem. Apple's actually been quite innovative as far as this goes because they've worked hard on things like the Gorilla Glass so that they can have these glass-fronted devices that would previously have been impossible. There have been quite a few places where they've done this. The CNC tooling for the new MacBook Airs, they've been very innovative about making things that used to be impossible to manufacture become possible to manufacture. So another thing that needs to be considered is the actual electrical design and engineering, the circuits. Again, you need someone here that knows this stuff. This is easier than it used to be back in the analog days in the 1800s. You had tubes and coils and horrible things like this. Now almost everything's digital. You don't really even need to be an electrical engineer, you just need some domain knowledge to plug things together. I'm lucky enough that I am an electrical engineer, so I have that domain knowledge, but I don't think you really need to be one. So this encompasses things like the design of the interface, the buttons, the screens, the panels, the LEDs, basically the I/O. It encompasses the actual design of the circuit, which covers things like selecting the components. You have to know what is actually going to go on. You know, you can't just plop down any random resistor. It has to be the right resistor. This also covers some manufacturing. The circuit board needs to be designed. This is something that is kind of more art than science. There's quite a lot of voodoo to this. And there are automated systems that make it easier, but it's still rather difficult to do. It has to get manufactured. So at this point, you're looking at business relationships with manufacturers. You have to look at volumes and scales, and you need a business plan to have an idea of how much stuff you have to order because you don't want to end up warehousing everything. The components have to be attached to the circuit board. It actually has to be put together somehow. So these are all fairly significant hurdles to building these things. There are other issues. Power, for example. How is this device going to be powered? If it just sits there and doesn't do anything, it's probably not going to be too exciting, so it probably needs some source of power. You could use a wall plug, but if we're talking about something portable, that's probably not a good idea to carry your own little generator with you all the time with the device plugged into it. Probably not quite what you want to do. You can use batteries, but if the thing takes a lot of power, the user would have to change the batteries fairly regularly, and that's probably not going to be very, very nice to them. Or it can be rechargeable, and that's what most consumer electronic portable peripheral devices are doing today. There are a lot of different ways of doing this. You can have it charged via USB, you can have a charging plug like in these two watches that are up here. The bottom one actually is mine, and that charging plug is kind of a pain, so that's maybe not the best solution. You can have some sort of a base station that the thing sits on, and this is something that's gotten a little bit better. In the past, your device needed some contacts, some electrical contacts where it would touch the base station. Now, what's called inductive charging has gotten popular, and you see this on things like the Sonic Carrot toothbrush, where there's no actual physical connection. You just bring it close to the charging station and it can charge. Apple just filed a fairly interesting patent regarding this. That might give us iPhones with infinite battery life at some point if their patent actually works out. So there are innovative ideas with this, but it's still something that needs to be thought about. Another issue is the actual manufacturing. As I mentioned earlier, not just with the electrical portions, but with the device itself, the device and its packaging. You need to get this stuff made somehow. And the way that this is generally done today for large things is Asia. And wow, you really can't see the screen at all, can you? And so this whole idea of manufacturing things in Asia, the reason that people do it is because it's cheap, but obviously it brings up ethical issues. And possibly, if you're going to be doing these things, you might want to manufacture in the US for ethical reasons, but then you have a higher price point, so there's a lot that needs to be decided here. Clearly the cost is almost always the most important aspect, but there's also the logistics of it. You have to get the supplies to the plant, you have to get the electrical components to the plant, everything has to come together, you have to figure out how the completed device is going to get from the plant to the consumer, and that brings up the question of distribution. You can make these things and you can have them manufactured, but if consumers can't actually find out about them or get them, then what have you done? Nothing. So distribution is a significant problem. If you're going to do something like get your stuff into Target, then you need fairly significant agreements, and you probably need some sort of venture funding or to be very independently wealthy to pull that off. If you want to just sell over the internet, that's significantly easier, but you still have marketing. So yeah, these are tough things. So basically, what I've gone through is showing that there are a lot of problems with actually making peripherals. And this is fairly negative, but we're going to talk about some solutions to these. But before we get to that, let's talk about the communication. Because as I said, these peripherals probably need to talk to your iOS device because they're kind of boring if they don't. And in the past, this has been a significant problem with peripherals because this communication is hard. The way that I'm going to talk about specifically is using Bluetooth. And Bluetooth has had a lot of problems. Basically, it's been fairly lame. So you see this dude up here in the corner with his kind of douchey Bluetooth headset and his kind of douchey business guy haircut and his lame sunglasses. This is pretty much how Bluetooth has been, kind of douchey. The problem is that if you wanted to do anything interesting with Bluetooth that's not predefined by the Bluetooth Special Interest Group, then you needed to create a profile for your new usage, and you needed to submit this profile to the Bluetooth Special Interest Group. And they would sit on it for about a year and debate it and think about it. And after that year, they would probably tell you that it had problems, and then you would modify it and then resubmit it, and another year would go by, and then they would finally approve it. At that point, you would have to wait for the smartphone manufacturers, the Apples and the Motorola's and the Googles and the Androids and all of those people to actually implement the profile in their device and then wait for that to actually come to market. So you're probably looking at another 3 years. So clearly, this never fucking happened, clearly. The hurdle was completely massive. This never happened. That's a fairly major issue. But even on top of that, Bluetooth uses a lot of power. Bluetooth has a constant streaming connection between the peripheral and the smartphone. And this sucks tons of power from both things. So you can have these Bluetooth peripherals that use these predefined protocols, and they're still not really that good because you have to change the batteries or recharge them or whatever fairly often. And finally, if you make a Bluetooth peripheral, it has to be included in Apple's Made for iPod program that we talked about earlier, and it has to go through this Apple certification and the $75,000 of testing and so on and so on. So, significant problems with using Bluetooth. Okay, so I've gone through a ton of stuff that makes you say, right, I'm never making peripherals, this sucks, this is terrible, there are so many problems with this, why would I ever want to do this? So let's kill the negativity, and if you can see the slide, it says enough negativity already. And we'll talk about why this is changing and why things are starting to be much better and why this peripheral market is going to take off in the next couple of years. The first thing is Bluetooth Smart. There's a branding problem here. This began the world as Bluetooth 4. It's a new iteration of Bluetooth that was called Bluetooth 4. And then they began calling it Bluetooth Low Energy, Bluetooth LE. And there's even a Bluetooth LTE in there somewhere, and I don't even know what the T stands for. And then they decided that Bluetooth 4 and Bluetooth LE were too geeky, and so now it's Bluetooth Smart. They're all the same thing. Basically, it's a new iteration of Bluetooth, and it fucking kicks ass. So, there's one profile in Bluetooth Smart. As opposed to these profiles that you had to get certified before and go through the Bluetooth Special Interest Group and wait for the device manufacturers, in Bluetooth Smart there's one profile. And if you want to do something new with Bluetooth, you just build a service on top of that profile. Nobody has to approve anything. You don't have to wait for the device manufacturers. You just build it and you can deploy it instantly. And you don't necessarily even have to pair. You can do things like have the device transmit to everyone. The only time that you need to pair with your smartphone is if you want encrypted communications. So right off the bat, this is much, much easier. You don't have to do any approval, you don't have to wait for any manufacturers. Another big thing is Bluetooth Smart does not require inclusion in Apple's Made for iPod program. The only approval that you need is App Store approval. So at this point, you've lost this necessity to be a device manufacturer and go through multi-months of getting included in Apple's program and certifying things and going back and forth with their approval process. All you need to do is be an app developer and get your app included on the store. Power. We talked about how Bluetooth devices use lots of power. Bluetooth Smart is smart, and the marketing copy that they're claiming is that a Bluetooth Smart device that's working as a Bluetooth Smart device is intended to work can be powered for a year, 1 year, on a single coin cell battery. That is a big deal. So all of a sudden you have little tiny things that can actually even be disposable. If it's a coin cell battery and a $5 chip, you can start making disposable devices. You couldn't do this before. It's not a panacea. Bluetooth Smart does not do everything that conventional previous crap-ass Bluetooth did. There are limitations. The first is Bluetooth Smart is optimized for doing small transmissions, whereas before you had this constant stream between the two devices. Bluetooth Smart is optimized for just sending little bursts back and forth, and these bursts are small, so you're not sending files, at least not big files. You're not sending video, you're probably not sending live audio. These are small transmissions. And these transmissions should be infrequent. They should not be on the millisecond range. They should be on the second range. So maybe you send one transmission per second. That's about as much as you should be doing with Bluetooth Smart. So this is kind of a different use case. With conventional crap-ass Bluetooth, you were doing things like having audio headsets and streaming video. With Bluetooth Smart, you're looking more at things like heart rate monitors and a thermostat that talks to your cell phone to tell you the temperature in the room, or to let your cell phone configure the temperature in the room, things like that. So it's a different use case. There's another thing that's groovy about Bluetooth Smart. Basically, you have turnkey modules. These are things where companies have taken a Bluetooth chip, built it onto a very small board. This chip that you see here in the corner is about the size of my pinky nail. So this is a very, very small chip. So they've built it onto a Bluetooth board, they've added an antenna, they've added the components that you need to actually use the chip. And most importantly, they've pre-certified it in all of the major all of the major world markets. So this turnkey module that you see here, it's FCC certified, it's UL certified, it's CE certified, it's CCC certified for China. It's ready to rock. All of a sudden you have significantly less effort for getting your device to market. You don't need these certifications anymore because you're using this turnkey module. That is really, really nice. So it's the same hardware, but it's pre-certified. It also reduces the amount of engineering effort that's required to get your peripheral to market because they've done a lot of the work for you. You don't need to worry about the antenna design, you don't need to worry about these components coming together, you basically just need to worry about how to get it power and how to communicate with it. It's reducing your engineering effort quite a bit. There's a drawback, it costs more. The raw chip costs somewhere in the neighborhood of $3 to $5 for a Texas Instruments chip. There are other options, but I think the TI is the cheapest at the moment. These things cost $20 or $30 per. So you're looking at a significantly higher cost per unit, but depending on what your volume is and what your engineering effort is and what your requirements are, it can definitely be worthwhile. Okay, we're nearly done. What I mentioned at the very start was that there are a couple of broad trends in the world today that are coming together that are going to make this market big in the next few years. And for the sake of this talk, I'm going to call those the perfect peripheral storm. Basically, these things are coming together and stuff's going to get cool. So, a lot of this has to do with the hobbyist market. The first thing is this board that you may have heard of called Arduino. And Arduino is a small microcontroller, an embedded microcontroller, that has quite an active development community built around it. Basically, hobbyists can use this board and program it in a C-like language, which I guess is also kind of JavaScript-like. And it's based on processing, which you may have heard of, which is a graphical, designy type language. So you can program this board with fairly low effort, and you really don't need to know what you're doing particularly well. And there's a big hobbyist market that's built around this. Essentially, electronics is becoming fun, and electronics is becoming something where people do it just for the hell of it. They kind of treat it like Legos, grown-up Legos, and plug things together with these Arduino boards, and in the last 2 or 3 years, these have just become massive. So that's really the first big thing. There are all these people playing with electronics. There is a Bluetooth 4 module that you can, a Bluetooth Smart, module that you can plug in to one of these Arduino boards. So all of a sudden you can build something for about 35 bucks that can talk wirelessly to your iPhone. No one has to certify anything. You could sell these, period. Here's the URL that you can't see at all because you can't see the screen, but there is a URL for the Arduino community. So the next thing is...
I think there's a meetup at 6 p.m. tonight at Joanne's for this board.
Oh. Okay, so Craig has just told me that there's a meetup. Sorry? Oh, Chuck, sorry. Chuck Soper, at least I got part of it right, has just told me that there's a meetup tonight at Jillian's at 6 o'clock p.m. For the Arduino hacker community. So if you're interested in this, that would definitely be a good part 2 of my talk. So the next important thing is that there is quite a big community that's being built up around electronics hobbyists and electronics hacking. Someone that's really kind of driving this community is an online company called Sparkfun Electronics, and they are trying to put the fun in the spark of the electronics. So this is the store. This is someone that you can buy your electronics kit from. They sell these Arduino boards, they sell Bluetooth modules, they sell lots of different things. But more importantly, they have a lot of how-to articles, and they have very helpful forums where you can get advice for when you're stuck. So that's pretty helpful. There are a lot of blogs that you can see and YouTube videos that you can watch. And the one that's kind of leading the pack is this EEV blog with Dave someone, the guy looking kind of crazy in the photos. And this guy does a weekly electronics YouTube series where he talks about all aspects of electronics hobbying and how you can move forward with these. And I cannot recommend this highly enough. His video series is absolutely fabulous. If you need to know which oscilloscope to buy, you can watch him dissect 3,500 of them, and they're really, really good. The next important thing that's coming together that's going to make this market big is the rise of 3D printing, and specifically affordable 3D printing. So all of a sudden, you have a lot of people that are starting to make physical objects and iterate and design physical objects in their home or in their office. This used to be something where if you wanted to do this, you had to talk to a manufacturing plant and figure out manufacturing and details and materials and so on. Now you can prototype easily and quickly here in San Francisco. There's a place just a few blocks away from here that has a selection of 3D printers. And you can go in, take I think it's a $90 course from them, and you can then go in and print whatever you want. I think you just pay materials. And I actually can't remember the name of this place, but I'll find it out. And, sorry?
There's one called Tech Shop.
Sorry?
Tech Shop.
That's it. Yep, it's Tech Shop. And I think it's in the Mission, between the Mission and Potrero Hill. So it's like right around the corner, and you can go in and print things. So this is the second big thing that's going to drive adoption of peripherals. All of a sudden, it's really easy to make hardware. And finally, distribution. You're starting to see a lot of online shops for makers. You can design your thing, you can print it up a couple of times and get the kinks out of the design, and then you can upload that design, both electronic and physical, to online distributors, and they will make your stuff, and they will sell it to the public for you. And of course, they take a big cut, but who cares? At least you're doing it, at least you're getting it out there. So you can be a hobbyist for the electronics design, you can be a hobbyist for the physical hardware design, and you can have a middleman, but a fairly efficient middleman for the actual distribution. And you don't really need to get certified because of the turnkey module, and you can communicate with your iOS device for free because you don't need to be included in Apple's MFI program. So one of these online distribution things is Ponoko, who knows? It's Ponoko, we'll say. And you can check them out. They're fairly cool. And yeah, essentially you give them your stuff and they'll get it sorted. And so last, as I said, is this Bluetooth Smart. It makes it so that you don't need certification, and it pretty much covers all the bases. So that is more or less it. I hope that you guys have enjoyed this. I hope that you do see now why I think that this peripheral market is going to be so mammoth in the next few years. All the pieces really are coming together, and all of that pain that I talked about at the beginning, some of it's still there, most of it's gone. And more importantly, the pieces are falling in place for all of it to be gone. I think things are just going to accelerate, and I think that this is going to be an exciting couple of years as far as hardware goes. So, I'm Jason Harris. I'm working at SourceBits, who, by the way, you can't see it on the screen, they are hiring. So, if you're looking for work, you might drop me a line or drop them a line. They mostly do software, even though I do hardware, so it's approachable. And again, thank you very much to StackMob and to Appsterdam and to Rob and Judy for organizing. And thank you all for coming. Does anyone have any questions?
Hi. What do you think about AntPlus and how's it gonna evolve or compete with Bluetooth Smart? I mean, considering that AntPlus.
So the question is regarding AntPlus. This is another competing communication protocol to Bluetooth, and I mentioned it briefly at the beginning. It's what my watch is using to communicate with whatever it communicates with. And it's actually a really nice communications protocol. The problem is that none of the computers or mobile devices are supporting it natively, or if they are, I don't know about it. It's not supported natively in iOS. So to actually do any sort of communication, you need to plug some sort of a physical dongle into your device. And anytime that you talk about dongles, it's not so nice because then you have to know where the dongle is, and I don't know about you guys, but I don't know where my dongle is. That's a problem. So it's a nice... Oh. So it's a nice specification, but in the real world, maybe it has some problems. I hope that's not on video. More questions?
What does the Nike Plus use? The Nike Plus use?
So the Nike Plus, the question is what communication protocol the Nike Plus is using. I'm actually not sure. I think in the past it was using the same Ant Plus that you just asked about, but I'm not sure how it was actually communicating with the device. Yeah, I'm not sure actually. I don't know what it uses. Does anyone know? Sorry?
You talked about how Bluetooth Smart kind of is moving towards low energy and what sounds like high latency kind of devices. Is there any technology that's been introduced to users that do high bandwidth and low latency applications such as controllers or streaming video?
So the question is whether there is any technology that's similar to Bluetooth Smart. Bluetooth Smart is optimized for high latency, low frequency, infrequent and small transmission type stuff. And the question is whether there's anything that does high bandwidth, low latency, specifically like for controllers. And I would say actually that that's probably conventional Bluetooth. That's what it's optimized for. But again, you have this problem of certification and of power consumption. So if you're looking for something that's high bandwidth, low latency, and low power, that's difficult. I'm not aware of anything. Wi-Fi, maybe.
So they're kind of trying to find the high density, low energy, kind of not focusing as much as they used to on
That's absolutely correct. The Bluetooth Special Interest Group sees Bluetooth Smart as a totally different product. There are actually chips, hardware chips, that are what are called dual mode. So if you're in the phase of like a multivariate communication where you need the infrequent communication, you can be in Bluetooth Smart mode. But then if you need to do something that will do some sort of high bandwidth thing, then you can switch over to conventional crap-ass Bluetooth, and you can switch back and forth using the same hardware. And those chips, they're NDA'd as far as price goes, so I'm not actually sure what the price is, but they're what's in the iPhone 4S, for example. There's a company called CSR that's doing most of the heavy lifting on this, and I think that those are what's in the iPhone. Well, no, I know that those are what's in the iPhone 4S. Any other questions?
So there's only two iOS devices that support Bluetooth Smart, right? iPad 3 and 4S?
That's correct. There's only two iOS devices, the iPad 3 and the iPhone 4S.
What about the hardware? Like the MacBook?
As far as Mac hardware goes, the most recent MacBook Air and the most recent MacBook Pro that was introduced on Monday support it, and the Mac Mini, the most recent Mac Mini supports it. Outside of the iOS world, the Motorola Droid supports it, and actually I haven't looked for about 2 months, so this info is all from about 2 months ago. Basically everything that's going to be released, at least high-end in 2012, will support it. So by the end of 2012, the majority of new devices on the market will be supporting this.
It's more of a comment. I might be wrong about Jillian. So I heard about the meetup I told you about on a list. It's a meetup group called Silicon Valley iOS Developers Meetup. So it'd probably be best to sign up for that email list and find out what the status is. But I do have one question.
So about the Arduino hacker meetup that Chuck had mentioned earlier, it's possible that this is not actually happening. It's
Or a different location.
or maybe it's a different location, or maybe it's actually in Malaysia. So if you want to find out about it, check meetup.com.
I'm just wondering what the price point is for entry into having these devices. And one example is I saw a device, a guitar pick that looked really cool, and they were using the iPhone as a fret, and it was very successful. And he got funded through Kickstarter only.
So the question is what the price point is for entry into this market. A Bluetooth Smart development package from Texas Instruments, which is about the cheapest that I've seen, costs around $70. And this gives you, if I remember right, it gives you a little dongle, again, that can act as a server, and a second one that can act as a client, and I believe the debugging device that lets you connect these via USB to your fairly disgusting Windows environment. Now, there's a caveat with this. To actually program the firmware in these chips, there's only one way to do it. There is no open source way of doing it. The one way to do it is called IAR Workbench, and it is fucking expensive. I think it's about $3,000 per seat, dongle locked. The dongles keep coming back up again. I'm told that one could pirate it if one wanted to, but it's expensive. But you probably also need a basic electronics lab, so this consists of at least a multimeter, or probably an oscilloscope. So you're probably looking at about $600 to get all that together. This stuff is fairly cheap at this point. So yeah, let's say for under $1,000, you can be playing in this market fairly easily. Did that answer your question? Anyone else?
What's the data rate?
The data rate, I have absolutely no idea. I know that most transmissions are in the range of bytes. So when you actually send a packet, you're looking at probably under 200 bytes, and you probably want to do this in the range of once per second. So it's quite a low data rate. Sorry? No, a small image is actually okay. For example, I saw a demo of someone transferring V cards between Bluetooth devices. And the V card contains the image, and well, it contains an image of the person. And I don't know how big a V card is. I'd guess probably 500 or 600K. And these were being transferred in under a second.
Wikipedia says 200 kilobits.
200 kilobytes per second.
Bits.
200 kilobits per second. Yeah, that's a big difference.
Have you had experience with NFC or microcontroller and NFC
Experience NFC? Right, so the question is whether I have any experience with NFC near-field communication. This is something that's being used for a lot of like wallet-type solutions like Google Wallet. And this is another technology that uses, I think, no energy on the client device and can communicate with something kind of like a little control point that can get info from it. I do not have any specific experience myself with it, but as far as I understand, it's a bit of a different use case because it can only communicate something that's built into the device, I think. I don't think it can communicate arbitrary data, but I'm not positive about this. I've never used it.
I'm not sure about that, but it seems to do Android as an SDK to set.
Okay, so the comment is that Android SDK appears to be able to set data, so maybe I'm wrong about this. I know that it's built into a lot of Android devices. Maybe it's a competing technology. I understood that it had a bit of a different use case, but I haven't really looked into it, so I'm probably not competent to comment on it. More questions? Right. Okay. Well, thank you all again, and I hope that you guys enjoy the rest of Appsterdam and Dub and the beer drinking and whatnot. Ciao.